In this video, we're going to work through examples 2 and 3 from the 3.4 notes. And here we're going to use the rational zero test in order to find possible rational zeros and then to help us begin to factor a polynomial function. So in example 2, we are asked to find all possible rational zeros of this function, x cubed minus 9x squared plus 20x minus 12, so the same thing we did in the previous example 1, and then use the possible rational zeros to find all zeros and to factor f of x completely. Since f of x is a third degree polynomial, if we can find one zero using the possible rational zeros, then we'll have a quadratic and we'll be set. So we just need to find 1 0, and then we'll have a quadratic. So that's a goal. We can reduce it to a quadratic, which we know what to do from there. Okay, so first thing we're going to do is find the possible rational zeros. We're going to use the rational zeros test. So P are going to be factors of negative 12. Q is going to be factors of the leading coefficient, which is 1. So those values are going to be factors of P, which are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And the factors of the leading coefficient are just plus or minus 1. So our possible rational zeros, our complete list, is plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Okay, that's the first part of the problem. Now we want to use this to help us factor. So what we're going to do is we are going to guess one of these possible zeros, and then we use synthetic division to check if that is indeed 0. So guess and use synthetic division to check. And if we don't find one, we'll guess a different value. So you can choose whichever one you want to guess first. I usually try to guess something easy first, hoping that it will work. So I'm going to guess 1, positive 1. So I'm going to guess the 0. This goes on the outside of the L. With synthetic division, I'm going to put the coefficients of my function. So that'll be 1, negative 9, 20, and negative 12. There are no missing terms, so I don't need any placeholders. I'm going to go ahead and do the synthetic division. Bring down to 1. 1 times 1 is 1. Negative 9 plus 1 is negative 8. 1 times negative 8 is negative 8. 20 plus negative 8 is 12. 1 times 12 is 12. Negative 12 plus 12 is 0. So I am happy because what have we just done? We've shown that 1 is a 0. And we've also shown that x minus 1 is a factor. That's what happens when the remainder is 0. Right? That's what we're looking for with these synthetic division problems. So now we can start factoring our function. So f of x, we found that 1 is a 0, so x minus 1 is a factor. And then we can use these coefficients that are left in order to continue to factor. So what we're going to get here is if I look at these coefficients, this one is the x squared term because we started with x cubed. So it's going to be x squared minus 8x plus 12. So that's a quadratic factor, x squared minus 8x plus 12. And now if we're lucky, we can factor the quadratic. And this is actually a nice quadratic. We need two things that multiply to 12 and add to negative 8. So that'll be negative 6 and negative 2. So this is going to factor as x minus 1 times x minus 6, the quantity, times the quantity x minus 2. That's f of x in factored form. That's what we're asked to do. And then we are also asked to list all the zeros. So each one of these factors leads to 0, so leads to a 0. So we have 1, 6, and 2. Those are our zeros. Moving on to example 2, we're asked to find all possible rational zeros of a fourth degree polynomial function, which is listed out. And then we're going to use the possible rational zeros to find all zeros and to factor completely. So since this is a fourth degree polynomial, so this is a fourth degree, if we can find, our goal is we need to find 2 zeros with synthetic division using the rational zeros test to help us, and then we'll have a quadratic, and from that we have a lot of tools that'll help us factor and find the remaining zeros. Okay, so let's begin. We are going to list the possible rational zeros. So possible rational zeros, we're going to use the rational zeros test. So P is going to be factors of the constant term, so we need to think about negative 25, so we're going to do factors of negative 25, and Q is going to come from factors of the leading coefficient, which for this problem is positive 2. And now I'm going to list out the factors of 25, which are of negative 25, which are plus or minus 1, plus or minus 5, and plus or minus 25, and the factors of 2, which are plus or minus 1 and plus or minus 2. So I'm going to generate the list where I'm going to take each each factor from the numerator and divide it by each factor in the denominator. So I'm going to have plus or minus 1 and plus or minus 1/2. Then I'm going to move on to 5 and divide that by 1 and 2. So I have plus or minus 5 and plus or minus 5/2. And then I'm going to move on to the factor 25 and divide that by plus or minus 1 and plus or minus 2. So I'm going to have plus or minus 25 and plus or minus 25/2. That is the list of possible rational zeros. Okay, now we're going to use this list to help find zeros of our function using synthetic division. So I'm going to set up my little L. I'm going to put the coefficients from our polynomial in the first row, and you'll notice there are no missing terms, so we don't have to worry about that. So we're going to write 2, negative 15, 23, 15, and negative 25. On the outside of the L, I'm going to guess a zero. I'm going to guess an easy value first, so I'm going to go with positive 1. Hopefully that'll work. And now I'm going to do the synthetic division. So I'm going to bring down a 2. 1 times 2 is 2. Negative 15 plus 2 is negative 13. 1 times negative 13 is negative 13. 23 plus negative 13 is 10. 10 times 1 is 10. 15 plus 10 is 25. 25 times 1 is 25. Negative 25 plus 25 is 0. So the remainder is 0. So we're happy. And what have we shown? We've shown that 1 is a 0 and x minus 1 is a factor. At this point in the problem, we began with a fourth degree polynomial. When we divide by x minus 1, now we have a third degree. So this is a third degree quotient. So we need to do synthetic division again. So I'm going to pick the next easiest value and hope it works. We need to do synthetic division successively so that we can continue to reduce the degree of the quotient. Okay, so we need to do synthetic division successively, so using the previous quotient. So let's go ahead and do that. So I'll bring down the 2. 2 times negative 1 is negative 2. Negative 13 plus negative 2 is negative 15. Negative 15 times negative 1 is 15. 10 plus 15 is 25. 25 times negative 1 is negative 25. And now we have a remainder of 0. So we're happy. And what have we shown? We've shown that negative 1 is a 0. And x plus 1 is a factor. And now we can start factoring our original function. So we have f of x is equal to, we've shown that x minus 1 is a factor and x plus 1 is a factor. And now we're going to look at the quotient, and the quotient comes from the coefficients of our last synthetic division. And now remember, this is a second degree because we've gone from a fourth degree to a third degree and now a second degree. So the coefficients in our quotient from our last synthetic division are for a quadratic. So we'll have 2x squared minus 15x plus 25. And if we're lucky, this can factor. So I'm going to try to factor. You can either do guess and check or AC. I know most of you like AC, so I'll use AC. If you do guess and check, go ahead and do that on your own. So AC is 2 times 25, which is 50. So we're looking for two numbers that multiply to 50 but add to negative 15. So those numbers will be negative 10 and negative 5. So we're going to split the middle term as negative 10x minus 5x plus 25. Then we'll factor the first two terms by grouping. So this is going to give us 2x is the greatest common factor, leaving us with x minus 5. And from the second two terms, we can factor out a negative 5, leaving us with the factor x minus 5. And now this factors as 2x minus 5 times x minus 5. And I'll bring down these other two factors, x minus 1 times x plus 1. And so now we have indeed factored our polynomial completely. And once we have these linear factors, it's simple to find the zeros, setting each one of these factors to 0. So if x minus 1 equals 0, x equals 1, x plus 1 equals 0, x is negative 1. If 2x minus 5 equals 0, 2x equals 5, and x equals 5 halves. So our next 0 is going to be 5 halves. And if x minus 5 equals 0, we have a 0 at 5. So we have factored the polynomial function and found all the zeros.